So now everybody listen here. You're able to hear me? Yeah. Just say the question is, see here, if f of x is equal to 2 power tan x and x equal to pi by 2, you have to check the discontinuity of the function. So you know that f of pi by 2 plus is equal to 2 to the power of tan pi by 2 plus x. Tan pi by 2 plus. You know this is the graph of tan x. At pi by 2 plus means you get forward. So forward the graph is down. So minus infinity. Tan 2 to the tan power pi by 2 plus is minus infinity is the answer. So 2 to the power of minus infinity I can write as 1 upon 2 power infinity. 1 upon this 2 power infinity value is infinity. 1 upon infinity is 0. So left and right hand limit I am going to get 0. Then if I find the left hand limit f of pi by 2 minus, so 2 tan pi by 2 minus. So pi by 2 minus means backside of this. So that is going up infinity. See exactly pi by 2 not defined, but pi by 2 minus it will be minus plus infinity. So 2 to the power of infinity. So 2 to the power of infinity is infinity here. So now left hand limit and right hand limit are both are not same. So it is called as discontinuous function and it is irremovable or non-removable discontinuity type, and in that one is came infinity, so it is infinite type of non-removable discontinuity. Understood? Let's move on to the next question. I hope you understood now. Did you understand now? Hello? Yes. Now we will move to the next question. Okay. Already it is time wasted. Lot of. So here, one upon next question. Next question. I think yesterday I explained this question, right? Did I explain or not? Okay. Next question is f of x is equal to 1 upon x square and x is equal to 0. So you have this one. So limit extending to 0, 1 by x square, left hand limit and right hand limit. If I take plus, I get 1 by infinity square, 0 square. So infinity, 1 by 0 plus square, 0 plus square. That is 1 by 0 square. That is 1 by 0 is infinity you are going to get. Limit extending to, that is you are going to get infinity. Okay. Now if I take RHL, limit extending to 0 minus, that is 1 by minus 0 minus square. That is again positive. 1 by something is positive. 0, that is 1 by infinity. So infinity, you are getting both. LHL is infinity or RHL is infinity. Both are infinity. This therefore D and E limit means limit does not exist. Limit does not exist, and it is non-removable discontinuity, and it is infinite type of discontinuity. This is infinite type of discontinuity. Okay, is it clear? Can I go for next question? It is called as non-removable infinite type of discontinuity. Yes, clear now? Right. Fine. I think these are things I gave homework yesterday. Correct? And limit extending to 0. Next one. Next one is limit extending to the, this one you have done, right? F of x is equal to sine 1 by x. F of x is equal to sine 1 by x. Or f of x is equal to cos 1 by x. And x is equal to 0. What type of discontinuity? So I told you already, limit extending to 0 plus, that is sine 1 by 0 plus, that is sine infinity. Sine infinity, this is oscillated discontinuity here. So this is, you can take, it is called oscillated discontinuity. This is called as what? Oscillated discontinuity. So non-removable oscillated discontinuity we call. If you take 0 also, whatever it may be, you get minus 1 to plus 1, it is oscillated. So this is called as oscillator. So we have completed types of discontinuities. All types of discontinuities we have completed. Now we will do the problems again, and last finally we will solve intermediate mean value theorem. Okay, intermediate mean value theorem also we will do it. Okay, did you understand this? Everybody understood? Types of discontinuities understand? Understood or not? Okay, next questions. Find the question is, find the points of discontinuity of the following functions. Find the point of point of discontinuities, discontinuity, discontinuity of the following, of the following. Okay, question number 1. F of x is equal to 1 by 2 sin x minus 1. F of x is equal to 1 by 2 sin x minus 1. You have to find the point of discontinuities here. Point of discontinuity. How many points it will be discontinued? Okay. So the question is, there will be two questions. Question number 1, 0 to 2 pi. Okay. Question number 2, in real. If it is x is real. Okay, two things are there. Find the point of discontinuity of the following function. F of x is equal to 1 by 2 sin x minus 1. So what to do here? Just we have to solve here. Take the denominator. Whenever denominator equal to 0, that is called discontinuity here. So what I can do here? 2 sin x minus 1 is equal to 0. Should not come. Okay, if it is comes, then it is a discontinuity here. So I can write as 2 sin x is equal to 1. So sin x is equal to half. When you get sin x is equal to half, when you get a sin x is equal to half, what is the general solution for sin x is equal to half? Tell me, one of you tell me, what is the general solution for sin x is equal to half? Tell me, x is equal to n pi plus minus 1 to the power of n alpha. 1 by 2 will get at pi by 6. So this is the general solution for this. Yeah, this is the general solution. Means how many points it is discontinued? How many points it is discontinued? How many points discontinued? See here, 2 sin x is equal to 1. Sin x is equal to half. So x is equal to n pi plus minus 1 by minus 1 power n pi by 6, where n belongs to integers. So infinite types, na? Integer means n is integer means infinite points. It will be discontinued in infinite points. But if anybody asks 0 to 2 pi, how many times? 0 to 2 pi means you have to draw the graph of sin x. Let's draw the graph of sin x. This is the graph of sin x between 0 to 2 pi. This is 0 and this is 2 pi. And you know that sin x equal to half. Half line is, this is the line. This is the line half. Y is equal to half. So here you are going to get, here is the here. So how many points you are getting discontinuity? 2 points. Here is 2 points. At 2 points it is discontinuous, and here is infinite points. Infinite points it is discontinuous. Understood? Again lost. See, I can't do anything here. Always connection is lost. Hello. Sorry, it is again lost the connection. So you have to wait. Hello. Yes. Oh, this is you have listened or not? I don't know. And it is the connection is lost. What's going on? Yeah, everybody listen here. I think connection lost again. It is came. We came back. Hello. Yeah, please listen here. I think again it is reconnected. Listen to me here. Find the point of discontinuity of the following function. F of x is equal to 1 upon 2 sin x minus 1. So you have to find in the interval 0 to 2 pi and complete real number on real number. So what I want to say here, I take the denominator is equal to 0. So if I take the denominator is equal to 0, 2 sin x minus 1 equal to 0 here, then sin x is equal to half you are going to get. Sin x is equal to half. So sin x is equal to half, general solution is x is equal to n pi plus minus 1 whole power n pi by 6. So general solution you know na, sin x is equal to sin theta, x is equal to n pi plus r plus minus 1 power n theta. So this is a general solution. So where n is an integer, so it will be discontinued in infinite points. At infinite points it will be discontinued. Infinite points discontinuity. And it is again lost. Yeah, it is called as it is discontinuous. Infinite point discontinuity. So this is what type of this one? Which type is this? Is it? It is called as isolated. Okay, and one more thing is here 0 to 2 pi. If I want to see 0 to 2 pi, 0 to 2 pi it will cut at 2 points. 2 points it is cuts. Pi is equal to half line cuts at 2 points. So 0 to 2 pi, 2 point of discontinuity. On real number it is infinite point of discontinuity. Understood? Did you understand? Did you understand this question? Hello? Did you understand what I explained? Hello everybody. Voice is not clear. Study also this is not useful. Yeah, now tell me, is it voice is clear now? Is the voice is clear right now? Continue. Okay. So you understood this one? What I explained, understood? Yeah. We are going to solve today some problems, then we are going to start intermediate value theorem. See, I have told you what types of discontinuities are there. So I explained what types of discontinuities, that is over. And the final topic is there, that is intermediate value theorem. Okay, that is the last concept of the continuity. But before that, I am going to solve more questions, many questions on this. Okay, let us talk about another question. Let's take the another question. Next question is f of x is equals to 1 upon x square minus 3 mod x plus 2. 3 mod x plus 2. Find the point of discontinuity of the following function. Find the point of discontinuity. Point of discontinuity. Discontinuity. Find the point of discontinuity of the question. Okay, mod. This is mod x. Okay, you have to find the point of discontinuity here. Okay. Now you have denominator. Whenever you have a question find the point of discontinuity, you take the denominator. Modulus of x square minus 3 modulus of x plus 2 is you have to take 0. When it is 0, then only it will become discontinuous. So you can find here mod x square equals to, you can take something theta or p here. You can take p here. So I get as p square minus 3p plus 2 is equal to 0. So if I draw here p square minus 2p minus p plus 2 is equal to 0. P take out common, p minus 2 plus minus, I can take p common, 1 common, I get p minus 2 is equal to 0. So p minus 2 into p minus 1 is equals to 0. So P is nothing but what? Modulus. P is nothing but what? Mod x is equal to P. Sorry, mod x is equal to P, not mod x square. Mod x is equal to P. So you get P square minus 3P plus 2. So I can write as P is equal to 2 or P is equal to 1. That is mod x is equal to 2 or mod x is equal to 1. So x is equal to plus or minus 2, x is equal to plus or minus 1. So it will be discontinued at four points. At 4 points, this function is discontinuous. How many number of points it is discontinuous? 4 points. Understood? Did you understand this? At 4 points, the function is discontinued at 4 points. At what points here? Minus 2, minus 1, 1, plus 1. At these 3, 4 points, the function is discontinuous. Purva, understood. So T, okay. Let's go on to the next question. Okay. Okay, next question is, see, I will also share the video after this. Okay, find the point of discontinuity. Find the point of discontinuity. Point of discontinuity. Discontinuity. Find the point of discontinuity of the function f of x is equal to 1 upon x power 4 plus x square plus 1. Tell me what is the answer. Find the point of discontinuity. Find the point of discontinuity. Athar Jagtap 4, that is okay. Previous one correct. Now tell me, find the point of discontinuity. What is the answer for this? Find the point of discontinuity. Come on, tell me everybody. Tell fast. What is the point of discontinuity here? Now see, this is the denominator x is power 4 plus x square plus 1. It must be 0. Then only it is discontinuous. But whatever you keep here, x belongs to real, this is always positive. It is always positive. It is not going to get 0 anytime. You are going to get positive. There is no 0. You are not going to get 0 this one. So it is always continuous. X belongs to R. It is always continuous. Always continuous. There is no, so 0. So find the number of point of discontinuity means 0 point of number of, if they ask, then 0 point. If they ask find the point of discontinuity means no point of discontinuity. No point of discontinuity. And if they ask you find the number of points of discontinuity, then 0, and it is continuous. Always it is continuous. Always it is continuous. Always it is continuous. Okay, 0 points. Right, correct, Purva. Now let us move on to the next question. Yeah, next question is, next question. See, today I will explain all the questions. Tomorrow we are going to start intermediate value theorem. Otherwise, maybe I may start today also intermediate value theorem. So f of x is equals to 1 upon 1 minus e to the power of x minus 1 by x minus 2. Find the point of discontinuity. Find the number of points of discontinuity. Find the number of points of find the number of points of discontinuity. Points of discontinuity. Find the number of points of discontinuity. Now tell me how many number of points this will be discontinued. F of x is equal to 1 minus e raised to power x minus 1 by x minus 2. What is the answer for this? Can anybody tell me? What is the answer? So first answer must be here. Listen to me carefully. Here will be two answers. This one is the more here. This is the denominator. You see that it must not be 0. So this must not be 0. It means that x minus 2 is not. It should. If it is 0, then you get point of discontinuity. So x is equal to 2 will be creates the point of discontinuity here. X is equal to 2 will create the point of discontinuity over there. Okay. And the next discontinuity where it is happens, where happens the next discontinuity? Look at this point where, yeah, I'll show you here x minus 1 equal to 0. This will create the point of discontinuity. Reason why it is creates the 0? Here if I keep x minus 1 is equal to 0, x is equal to 1, then 1 minus 1 is 0, e to the power of 0. E to the power of 0 is 1, then this denominator, the whole denominator is going to become 0. So this point, this point becomes 0 when x is equal to 1. So there are 2 points of discontinuity here, that is x is equal to 1 and x is equal to 2 are the point of discontinuities. Yes, yes. 1 and 2. X is equal to 1, x is equal to 2 is the number of points are 2. 2 number of points. Understood? Did you understand all? Understood. Yeah, fine. Next question. Next question. Let's start the next question. See, the next question is f of x is equal to, this is a wonderful question. Write down, find the number of discontinuities, the number of discontinuity, this number of discontinuity of f of x is equals to greatest x minus greatest integer x minus 1. So here greatest integer x is greatest integer where this is denotes GIF. Represent the greatest integer, find the number of points of discontinuity. Question is, find the number of points of discontinuity. Find the number of points of discontinuity. This is the question. Okay. Find the number of points of discontinuity. Here f of x is equal to greatest integer x minus greatest integer x minus 1, where is represents GIF. Find the number of points of discontinuity is the question. Okay, tell me what is the answer? What will be the answer? What will be the answer? Can I explain? Okay, I will explain here. You know that greatest of, see, you have one thing. Suppose you have greater 2.3 is there. Okay, let us take 2.3. What is the greatest integer of 2.3? What is the greatest integer of 2.3? That is equal to how much? 2. And so again for that you are making again greatest integer. What I get here? That is also I get 2. This greatest integer of 2.3 is also 2. Greatest integer of 2.3, greatest integer again, also 2. Therefore, we can say that greatest integer of x of greatest integer is x only. So f of x is equal to, this is always x. And you have learned greatest integer of x minus any integer. x plus any integer will be giving as greatest integer x minus 1. Means greatest integer of any number you are getting, any number is there, integer is there, integer will go out. Greatest integer of x plus integer is equal to greatest integer x plus integer you are going to get. Same way here I am going to get as greatest integer of x minus 1 I am going to get. It means I am going to get x minus greatest integer of x is see greatest integer of what I am going to get, greatest integer of x minus 1. So I am going to get how much x, and this I am going to get plus 1. So plus x minus x cancel, answer is 1. So y is equal to 1 is a straight line. Y is equal to 1 is a straight line. It is always continuous. It is always continuous. Yes, continuous, Purva, correct. Yes, yes. It is always continuous. There is no point of discontinuity here. No point of discontinuity here. Okay, you can write like this. It's better way is to write this answer is, this is the better way. I'll just write it again. Greatest of greatest integer is, I can write greatest integer x, and this I can write as greatest integer x minus 1. Okay, I can write this one as like this. Greatest integer of x minus 1 is greatest integer x minus 1. Again you get here greatest integer. I get minus greatest integer plus 1. Greatest, this is cancel out. I am going to get 1. So y is equal to 1 is a straight line. So it is always continuous. Okay, understood? Understood everybody? Everyone understood here? I think greatest integer x we cannot write directly x, no? So that's better is you can write greatest integer of greatest x is greatest integer x minus, this is I can write as greatest integer x minus 1. So I can write minus greatest integer x plus 1. So it is cancelled, y is equal to 1. Yes? Yeah. So this is the way, number of points, whenever you ask that, whenever the question is came, number of points of discontinuity, you just check that where the function is not defined. Okay. If you know that where the function is not defined, then you can know the point of discontinuity of the any function. Is it clear to all? Is it clear? Understood? Let's move on. Next questions. You are copying this or not? Are you copying this? Are you copying these all or not? Okay, next question is f of x is equal to 1 upon 1 plus 2 raised to power 1 by x. 1 upon 1 by x at x is equal to 0. Find the point, find what type of discontinuity. Find the types of discontinuity. F of x is equal to 1 upon 1 plus 2 raised to power 1 by x at x is equal to 0. Tell me type of discontinuity. What is the type of discontinuity is this? What type of discontinuity is this? Are you understanding or no? Understanding or not? Purva. Understanding or little bit fast it is? Understanding na?
Understanding, sir.
Okay, fine. Then absolute is left side. What happened? Okay, cathode generally right side, anode generally left side. So same formula, cathode की जगह पे E right minus E left. So here is some. What happened? Infinite type, yeah. Infinite type is correct. F of x is equal to, I can write this is equal to, I don't know why two voices are coming. You're getting my voice clearly, you're getting or not? Are you getting my voice? 1 minute, 1 minute.
Here, formula E cathode minus E anode, E
What
right
happened?
minus E left.
So what I
Okay.
have told that is
Now,
not recorded now. Why is two voices are getting? Wait 1 minute. 1 minute. Wait. Please check now. Now is the voice is clear. Please check now. Please check now. Is the voice is clear now? Now also not clear. Okay, I do one thing. I'll do one thing. I'll share one more video. Okay. Now I'll stop this one. I'll share another one. We'll join in that. So I'll disconnect this one. I'll share another video. Okay.
zinc is converting into zinc plus 2, copper plus 2 converting into copper. In the between, that is shortage. It is one container, that is another container. Okay, so in the textbook they will give the question. In the question also, the PYQs we can see they will give here values. The zinc value is they will give like this minus 0.76. Here they will give 0.34. They will ask you what is the EMF of the cell. Then we have to do like this: E right minus E left, or E cathode minus E anode. Then you will get the answer. Okay, cell notation also you understood. Now, this electrochemistry, in the last class we discussed, see, this reaction is a spontaneous reaction. This reaction is spontaneous reaction. In the spontaneous reaction, how much electricity is producing? So, some amount of electricity is producing. Some amount of electricity is producing. Okay, that amount of energy may convert into mechanical work, may convert into any different works. Okay, same topic we learned in the thermodynamics class 11th. In a system, the useful work is known as Gibbs energy. The system, the useful energy is known as Gibbs energy. Gibbs, Gibbs energy. Here, whatever amount of energy is releasing, that is equal to Gibbs energy. Because this much of energy stored in the system, when we connected, then the energy transferring itself, that is spontaneously is going on. We are not heating these containers. Okay? So spontaneously, whatever work is done, spontaneously whatever work is done, that is what gives energy. Gives energy means in a system the useful work done. Okay? So your delta G equals delta G equal minus NFE. Invisible or not? Delta G equals E. Sir, minus क्या लेगा? We learned that Gibbs energy में how much negative is there, that much spontaneous. Yes, have you remembered or not? Gibbs energy, zero means equilibrium, positive means cannot react, cannot take place in reaction, negative means there is spontaneous reaction. It is spontaneous reaction, that's why minus. Then NFE, I will explain what is this NFE. Here N is number of electron transferred in the balancing equation. Since zinc is losing 2 electrons, so N will be N is 2 electron. What about F? F is Farad. F is Farad. So why we are using this Farad? Farad means one whole electrons charge. Current means what? Nothing but the charge. Okay. So 1 Farad means 1 Avogadro number electrons charged. Okay. Right. What is E? Is E only voltage difference? V is the voltage of the cell. So if you multiply these three values, you will get how much work done by this cell. How much work done by this cell? We will get by NFE. Maximum work done equal here NFE. That is the thermal energy that equal to Gibbs energy. Gibbs energy delta G equal to minus NFE. You understood it is number 1. Of course, I am taking here delta G naught minus NF E naught. What is this E naught and naught? Zero square. That means standard, that is representing standard. Standard Gibbs energy equal minus NF E naught. E naught means standard EMF. Whenever these two electrodes are placed in the standard solutions, standard conditions, that time whatever we are getting the voltage, that is standard EMF value. Okay, the standard EMF value into Farad into N is equal to work done by the cell. That is equal to work done by the cell, that is spontaneously. So that is equal to Gibbs energy. That is equal to Gibbs energy. So equation number 1 clear to everyone? Okay. Suppose if I take a different condition, delta G equal minus NFE. It is equation number 2. Equation number 1, if you understood, means equation number 2 is nothing but same. Different conditions. Stagnant temperature 25 is not required. Then concentration 1M is not required. Maybe different concentration. Okay, this much is clear. Right, step by step we can go step by step. Then I remove this figure now. According to Gibbs energy and this EMF, the relation is delta G equal minus NF E naught. It is number 1. Then delta G equal minus NFE. It is equation number 2. It is a standard condition. Right at standard condition. No need to write this one because not means only standard condition. Equation number 1 and 2 is over. Next. According to the thermodynamic equation, delta G equal, the relation between these two, delta G equal delta G naught plus delta G naught, the relation. Delta G naught plus RT ln Q. What is Q here? Equilibrium constant. R is the gas constant. T temperature. Okay. Then if you put these values here, minus NFE equal minus NFE naught plus RT ln Q. NF is there, so I am dividing with NF minus NF by minus NF by minus NF. Then those will get cancelled. So E equal E naught plus and minus is minus RT by NF ln Q. RT by NF ln Q. This is one equation. This equation derived by Nernst equation. Nernst equation. NERNST. Nernst equation. E naught minus RT by NF. They go maximum reactions. R is constant, T is constant, room temperature of that. F also constant, F means 1 Fahrenheit. F also constant. So if you take all these and ln equal, you know that ln equal 2.303 log. Okay. So here these many constants are there. So if you take all these, E equal E naught minus RDF also constant as well. This 2.303 also constant. If you multiply all these values, you will get 0.059 upon n log q. This is a final equation. You can remember directly. Sir, why you are not taking n also constant? It is not required. See, n for some reactions n equal to maybe 2, 3, 6, 1, whatever it is. It is depends on the balanced equation. Q equilibrium constant. Okay, then E naught is already yours. Okay, understood up to this? Here Q I will write here Q equal generally equilibrium constant. Equilibrium constant means you know that. Equilibrium constant. Equilibrium constant. EQM. Equilibrium constant. Okay, equilibrium constant means of that. Product the concentrations upon reactant the concentrations. The class level we discussed clearly. Okay, until this, do you have any doubts? No doubts? I will take one question. direct questions not there. Okay. So this concept over once I will check. Is it visible screen now? Yes, speak anyone? Okay. Right. See, these are the values. You can see here we discussed that zinc, zinc, then copper we discussed. Hydrogen electrode earlier, zero with respect to of hydrogen only. You are giving the above all values given minus. That means here suppose lead is there. Lead plus 2 taking 2 electron tendency is minus 0.13. That means it won't take electron. It will lose the electrons. But in case of copper plus 0.34, that means compared to hydrogen 0.34 times it is giving electrons, donating electrons like this. Sorry, my wrong word. Copper plus 2 is here taking electron 0.34 times, effectively taking. The lead is 0.13 times losing electrons. Right. So this is only non-rushing equation. I explain now. E naught minus RT by NF log product by reactant. So gas constant, temperature, these are all things. If you take RT by F constant 0.059, N2 as it is. Yeah, this question I will take. Okay, it is visible. 0.1 F copper sulfate solution. You can note down that question. 0.1 F copper sulfate solution in which copper electrode is there at 25 degrees Celsius. Calculate the electrode potential of copper electrode. Copper electrode. Okay. Then what's happening there? Copper 2 plus is forming into copper. That value is given 0.34. Is standard value 0.34. Now formula you can write direct. E cell equal E naught minus 0.059 by N log product by reactant. Product by reactant. So here, what is the product? What is the product here? 0.1 m concentration copper sulfate is there. So copper sulfate is forming into copper. Copper sulfate forming into copper. That means copper is product. Reactant is copper sulfate. What is the copper sulfate concentration? 0.1 m. Okay. Product by reactant. Product is concentration solid के लिए क्या होता है? 1 upon 0.1 that equal 10. Hello, now this screen is visible, board is visible now. You have to speak. Yes, board is visible now. Right. So you can see here 0.1 m copper sulfate solution is given. Copper plus 2 to copper 0.34 standard value already given. So I written here formula first of all. cell minus 0.058 by log P by R. What is being P for product by reactant? Why product by reactant? It is nothing but the equilibrium. Equilibrium में how we will write product concentration by reactant concentration, right? Now the question is, what is the product and what is the reactant? Here it is given clearly, copper plus 2 is going to form copper. Copper plus 2 is going to form copper. That means reactant is copper plus 2, product is copper. Right? Now put in these values there. E cell, that's only we have to calculate. E cell. Inert cell. Inert cell is standard form 0.34. 0.34 minus 0.059 upon n. Number of electrons exchanging. 2 electrons. Number of electrons, 2 electrons. Log product by reactant. Product is what? Copper. Copper is solid here. Copper is solid here. Okay, it is aqueous. So solution. Okay, product solid के लिए the equilibrium constant already we learned. For solids, the concentration will be taken as unit. That means 1. So 1 upon 0.1. You understood this step is over your problem. Yes, do you have any doubts in this step? No doubt means right, no doubt. Understood. If you have doubts, sir, why you are writing 0.1 down, why not half 2? Or why you are taking 2? Or any doubt, such doubt is there, yes, you can ask. Okay. Then 0.34 minus. See, numerical way, that is in our hand, we can do 0.594, we can take 0.06. 593 subtraction 0.06. So 0.06 by 2, that means 0.03. Okay, so 0.34 minus 0.03. Okay, 0.1 means what? Nothing but 1 by 10. 1 by 10 means log 10 हो जाएगा. So here log 10. Log 10. Next, since log 10 equal to 1. Log 10 equal to 1. So your value is 0.34 minus 0.03. That means how much? 0.31. That is your answer. Answer. See here, only important thing is the students will confuse and they will face difficulties here. Question is given, what is the product and what is the reactant? They did not understood. Maybe. So they will get problem here. What is the reactant and what is the product? So you can, some hint will be there, 100% they will give hint, but direct or indirect. Okay, here copper plus is given to copper, that means copper plus is the reactant, copper is product. Okay, sir, the E0, why you are taking 0.34? But it is given 0.34 the standard form, 0.34. E0 मतलब है standard form होता है. Okay, so these textbook में I showed you that these values in the textbook, these values are there, these are at standard conditions. Okay, now in this chapter and this equation purpose is to calculate at different conditions. Standard condition में textbook में already given, no need to do anything. Just you can remember. Okay, what is the purpose of this equation? At different condition, different temperature, different concentration. Okay, so whatever by using two different electrodes. Okay, so concentration, pressure, temperature. Okay, whenever these terms are changing, obviously the inert value will be changed. That's why we are going to calculate this. Okay, it is clear. If it is clear, then I will move to electrolytic cells. See, our chapter is 2 parts. In 2 cells, 50%, remaining 50% is there. So batteries and those things. In that 50%, 25% over. Electrochemical cells completed now. Electrochemical cells. Okay, next electrolytic cells are there. Electrolytic cells. Now it is 9:30. Still one period is there almost. Okay. See, you start solving questions from textbook. Yeah, you everyone as early as possible. You take this book.
The coding is being played, sir, now.
Topic wise questions are there. You have to solve.